So there are some special product forms in dealing with algebra. And the ones that you should be familiar with are the sum and difference of terms, which we have used already. And this was the case where if you have the sum and difference of terms and you FOIL it, what's going to happen to your outer and inner products? Here you get a squared is our first. Our outers are negative ab. Our inner is positive ab. And our last is negative b squared. Well, what's going to happen is always for the sum and difference of terms, these outer and inner products will cancel, leaving just the difference of squares. And so that's the shortcut. You don't need to go through the FOIL process. You just need to be able to recognize that when you take and multiply the sum and difference of the same terms, you can simplify its product by just finding the difference of the squares of the outer terms. All right, how many of you have been exposed to that even before we talked about it this year? Okay? That's called the difference, or the sum and difference of terms. Okay? You should also have been exposed to the binomial square. And if you take a binomial, two-term polynomial, and you square it, and this is equivalent to multiplying by itself, right? The utility of a power. And now if you were to FOIL this, your first term should be a squared. Your outer term would be ab. Your inner term is going to be the exact same product ab. And then your last term will be those last terms squared. And this is always going to be the pattern. And because you're adding the same thing, the outer and inner products will always be exactly the same. There is, again, a shortcut, special product form for binomial squares, and that is the first term squared plus twice the product of those terms, a and b, plus the last term squared. And so this is your shortcut for binomial squares. Okay, now, I'm going to go away and then come back in just a second. The binomial form has a particular pattern. If you take a binomial to the power of 0, what is that going to equal? 1. And what if you take a binomial to the power of 1? When you look at what this equals, it's a plus b, right? So it's 1a plus 1b. Okay. We just saw here, if you take a binomial and you square it, it's 1a squared plus 2ab plus 1b squared. Okay, so if you look at this, the pattern that is starting to form here is called Pascal's triangle. It's a pattern for some probabilities and some other things that actually happen in nature as well. But if you look here and you add the two values above the diagonal, you're going to get the new sum. So 1 plus 1 is 2. So if we look here at this next row, the 1s will stay on the outside. What's 1 plus 2? 3, and 2 plus 1 is? This Pascal's triangle pattern is going to give you the coefficients of each consecutive term in any binomial power. So a binomial cube, which you guys are going to need to, you should know the pattern for, fits this 1, 3, 3, 1 pattern. It's just this fourth row of Pascal's triangle. And what's going to happen here with the terms is the first term, a, will be taken to the power of whatever the whole binomial is taken to, cubed. And then each consecutive term, that power is going to reduce by 1. So the second term is a squared, then a to the first, and then a to the 0, which is not, it's a value of 1, so you don't need to write it at all. Okay, on the far right, this last term b is going to start at the highest power cube, and then it's going to move from right to left and decrease by 1 each time. So b squared, b to the first, b to the 0. Okay, so here is the pattern for a binomial cube. Okay, it's also the pattern for a binomial square if you struggle with that at all. So when we look over here at this other special product form that you need to be able to manipulate, and that's a binomial cube, the way that I would work with these, and you'll see as we go through examples, we may not get to them today, but if you recognize that you have a binomial cube, know that the pattern of coefficients is 1, 3, 3, 1. Leave some space in between to fill in what you have. And then you just take your first term as A. You're going to cube it, square it to the first to the 0, leave it blank. And then take your last term B. You're going to cube it, square it to the first, leave it blank. And you're just going to fill in your spots here. Okay, and so this right here becomes your binomial cube pattern.